Hermitian and skew Hermitian matrices. Okay, Hermitian matrix is very important in higher physics, like in quantum mechanics. A square matrix A equal to Aij is said to be a Hermitian matrix if A equals A dagger. So this is called a dagger. This symbol. Okay, you have a cross symbol, and what we call this as dagger. Okay, dagger. So it means A dagger. Dagger, the definition for dagger is nothing but take a transpose of a matrix and take the complex conjugate, or take the complex conjugate, take the transpose. I repeat, dagger is defined as you are going to change the rows into columns and take the complex conjugate, or take the complex conjugate and change the rows and columns. You have to apply two rules. The first one is you are going to take the transpose. The second one is you are going to take the complex conjugate. What is the meaning of complex conjugate? I becomes minus I. So you have imaginary number. For example, 5i. What is the complex conjugate of 5i? Minus 5i. Very simple. Suppose what is the complex conjugate of minus 6i? Plus 6i. Very good. That's all. Plus 6i. I becomes minus I. Minus I become plus I. Wherever you find I, you just substitute minus I. Wherever you find minus I, substitute plus I. Okay, so that's called complex conjugate. So we are going to apply two rules. One is transpose, then another one is complex conjugate. So either you can take the complex conjugate and transpose. Both are equal. You will get the answer same. For example, you just take this matrix A plus IC, B minus IC, and D. We are going to just take the complex. We are going to take the complex conjugate and transpose, or we are going to take the transpose and complex conjugate. Either way, the answer will be the same. We just take this 2 by 2 matrix. What is the transpose? What is the transpose of this matrix? A, B minus IC. Here it is B plus IC, D. Take the complex conjugate. This becomes, see, earlier A, B minus IC, here it becomes B plus IC and D. Now take the complex conjugate. This becomes A plus IC. This becomes A minus IC, which is equal to the same matrix. I repeat. See, this is 2 by 2 matrix. You are going to change the rows into column. First point. See here. Transpose means rows into column. So here A, let it be like this. B minus C will come here. B plus C will come here. You have D. So we have done the transpose. Now you are going to take the complex conjugate. So B minus C. What is the complex conjugate? B minus C. B plus C. Here B plus C. What is the complex conjugate of B plus C? B minus C. See, original matrix. So it means that this is dagger. This is Hermitian matrix. So if A equals A dagger, dagger is definition for dagger is given as this, and they are called as Hermitian matrix. See, 3 by 3 Hermitian matrix. This is your 3 by 3 Hermitian matrix. So change rows into column, column into rows, you will get the same answer. This is called Hermitian matrix. Very important thing is all Hermitian matrix will have real eigenvalues, real values. See, real eigenvalues. So we will see later. If A is a Hermitian matrix, then A equals A dagger, which is nothing but A transpose with complex conjugate, is real. Thus, every diagonal elements of a Hermitian matrix must be real numbers. See, they are all real numbers. Okay. A square matrix is said to be a skew Hermitian matrix if there exists minus sign. So wherever you find a skew, you just apply minus sign. So here it is positive sign. See here, positive sign. If it is minus sign, we call this as skew Hermitian. So we are going to change rows into column, column into rows, take the complex conjugate. Then one minus sign exists, we call this as skew Hermitian matrix. For example, you just take this 0, so take the transpose, 2 minus I will come here. You have minus 2 plus I. Now you have to take the complex conjugate, correct? So you have take the complex conjugate, that becomes see 2 minus I. So this will become 2 plus I with a minus sign. Or minus sign is there. So we have minus 2 plus I. Is it okay? So similarly for 3 by 3 matrix. So they are all skew Hermitian matrices. Then unitary matrix. A unitary matrix is a square matrix of a complex numbers whose inverse is equal to its conjugate transpose. Whose inverse is equal to complex conjugate. If this condition is satisfied, then this matrix is called a unitary matrix, whose inverse is equal to its complex conjugate, complex transpose. Alternatively, the product of unitary matrix and the conjugate transpose. See, and the conjugate transpose. So you have a unitary matrix and you have complex conjugate. The product of these two, either way, you can change also, you will get identity matrix. So, and the conjugate transpose of a unitary matrix is equal to the identity matrix. So this is identity matrix. 1, 1, 1. In the diagonal elements we have 1, 1, 1. So if it is so, there are two conditions. One is U inverse must be equal to the complex conjugate of that matrix. The second one is you take the complex conjugate, multiply with the original one, interchange also, that will give you the identity matrix, where I is the identity matrix whose order is the same as U. Orders must be the same. Order will be the same. For example, a square matrix A is said to be unitary if A dagger A equals I. The product of the conjugate transpose of a unitary matrix with a unitary matrix gives us the identity matrix. So the product of A dagger equals I. So A dagger equal to I divided by A. You just bring it to the numerator, we have A inverse. So A inverse equal to A dagger. So unitary matrix is a square matrix whose inverse is equal to its conjugate transpose. So conjugate transpose. For example, we'll have one problem. Show that's very important one. Show that the given matrix is unitary or not. The condition for unitary is A dagger A equals identity matrix. So you have A matrix is given by, you have this one. A matrix is given by this, correct? Now you are going to have A dagger. So you are going to have the A dagger. So what is A dagger? A dagger you are going to transpose and take the complex conjugate. So you have A dagger. A dagger means transpose and the complex conjugate. So what is transpose here? Transpose of this matrix 1 by root 2. So transpose means you have minus I by root 2, and here this becomes I by root 2, and this will be minus 1 by root 2, correct? Now you are going to take the complex conjugate. So that becomes 1 by root 2. Here minus I by root 2 we said. What is the complex conjugate of minus I by root 2? Plus I by root 2. And this term will come here. What is the complex conjugate? Minus I by root 2. This term let it be like this. Here. So this is your A dagger. Is it okay? So now A dagger multiplied by A. So this is your A dagger multiplied by A. Now what is the rule for multiplication? This one multiplied by this one, correct? So you know already. So this multiplied by this plus this multiplied by this. 1 by root 2, 1 by root 2. What is the answer? 1 by 2. 1 by root 2 multiplied by 1 by root 2. Answer will be 1 by 2. Here I by root 2 minus I by root 2. I into I squared. I squared is always minus 1, which you have learnt already. So you have this one multiplied by this will give you minus I squared. I squared is minus 1. So plus 1. 1 by root 2 multiplied by 1 by root 2, 1 by 2. So plus 1 by 2. 1 by 2 plus 1 by 2 is 1. I repeat, 1 by root 2 multiplied by 1 by root 2 will be 1 by 2. I by root 2 multiplied by minus I by root 2 will be minus I squared by 2. Okay. I squared is minus 1. Already one minus exists. So 1 by 2. Already 1 by 2. So 1 by 2 plus 1 by 2 is nothing but 1. Now you multiply this second term. Okay. This multiplied this will give you I by root 2. I by root 2 multiplied this will be minus I by root 2. Both will get cancelled. Answer is 0. You multiply this and this, answer will be 0. We will multiply this by this. So we have minus I squared by 2. So 1 by 2. Minus into minus plus. So answer 1 by 2. 1 by 2 plus 1 by 2 is answer is 1. So we have identity matrix. So A dagger A equals identity matrix. Any doubt? Example 2. Prove that the columns of the matrix. So we have columns of, see we have 2 by 2 matrix. So this is your column, correct? Column. Columns of a matrix are orthogonal. Okay, orthogonal. Orthogonal means perpendicular. Okay, orthogonal we are going to prove. Given matrix is this one. What is the column? So this is your column, correct? So this is first column, this will be your second column. So C1, C2. The product of orthogonal matrix is equal to C1 multiplied by C2 will give you answer as 1. Okay, let us see C1 and C2. C1 is this one, C1. Your C1 is here, C2 is here. So we are going to change into rows. So this becomes 1 by 2. This becomes 1i by root 2. So this is your column C2. You multiply these two. We will have multiply these two. So we have 1 by root 2 multiplied by 1 by root 2. Okay. Then we have this multiplied by this. So that will give you, this multiplied by will give you, you have I squared by 2. So 1 by 2 minus 1 by 2 I squared is minus 1. So 1 by 2 plus 1 by 2 will give you 1. So answer is 1. So the magnitude of each column is equal to 1. Hence the two columns of the unitary matrix are orthogonal. If this condition is satisfied, then we can say that the two columns of the unitary matrix are orthogonal to each other. Now what is the purpose? The purpose of learning matrices, we can solve some simultaneous equations. So these are all simultaneous equations. So we know already some equations. For example, probably you would have learned 2x1 minus 3x2 equal to 3, minus x1 minus 2x2 equal to 6, and we can solve this equation through matrices easily. Okay, so this can be written in terms of, see, we have, this is simultaneous equation. Okay, algebraic equation. This can be written in terms of matrices. 2 minus 3 minus 1 minus 2, x1 and x2 in a column matrix, which is equal to 3, 6. So we can get the value x1 and x2 immediately. Okay, so this is the way. See here, you multiply this one. So 2 multiplied by 2x1, see 2x1. Minus 3 multiplied by x2, see minus 3x2, which is equal to 3. So this equation can be written in terms of matrices easily. So that's the idea behind systems of linear algebraic equations. And of course this is a non-homogeneous equation, and which is equal to 0 means this is homogeneous equation. Okay, so this is the different term. If it is equal to 0, we call this as homogeneous equation. If it is not equal to 0, we call this as non-homogeneous equation. So this is a non-homogeneous equation. A11 x1, A12 x2. We can write these things in terms of matrices. So this will be A, and x, all x is represented of a column matrix. See like this, and that will be your capital X, and this will be B. So Ax equal to B. So this is the matrix representation of any simultaneous equation. Ax equal to B. Okay. So homogeneous, as I said, this one, and one obvious solution will be x equal to 0. Very important one, trace of a matrix. You add all the diagonals, the answer is the trace of a matrix. For example, you just find out the trace of a matrix. A11, A22, A33. You add all the three, see, summation over Aii, A11, A22, A33. So what we call this as a trace of a matrix. See here, this is the diagonal, these are all diagonal elements. You add all the three, so that will give you trace of a matrix. 1 plus 5 minus 5. So answer is 1. So this is a trace of a matrix. Very important one more question. You will be given a matrix and you will be asked to find out the trace of a matrix. Okay. Trace of a matrix. What are some properties are there? Trace of lambda A equal to, you can pull the scalar out, lambda trace of A. Trace of A plus B equal to, you can separate. Trace of A plus trace of B. Trace of AB equals trace of, if I want to interchange, the answer will be the same. The properties of transpose of a matrix will be, so these are some properties of trace of a matrix, and these are the properties of transpose of a matrix. A transpose of transpose will be the same matrix. When you are going to change rows into column, column into rows, the answer will be the same. A transpose of a matrix will be A. lambda A to the transpose equal to lambda A transpose, lambda being uniscalar. It can be a real or a complex number. A plus B to the power T equals A to the power T plus B to the power T. AB to the power T equals, you have to interchange and write B to the power T, A to the power. It is not A to the power T, P to the T. Okay, very important. You have to interchange and write. Orthogonal matrix. The condition for orthogonal matrix is this one. A transpose multiplied by A will give you I, identity matrix. So you have a matrix A, you are going to have the transpose of a matrix, multiply these two, that will give you identity matrix. And of course A transpose equal to A inverse. A square finite matrix A is said to be orthogonal if A transpose equal to identity matrix. A is an orthogonal matrix, then A transpose A equals also A transpose, which is also equal to I. An orthogonal matrix is a square matrix whose transpose is also its inverse. See here, this is inverse of a matrix. Properties of complex conjugate of a matrix. And of course you are going to take the complex conjugate for any matrix. So A star equal to A, it means that it's a real matrix. You are going to take the complex conjugate of, again complex conjugate, that will be the same number. For example, minus I. Take the complex conjugate plus I. Take the complex conjugate minus I. So you will have same thing. A plus B whole complex conjugate will be A complex conjugate plus B complex conjugate. Similarly, lambda A to the power complex conjugate of lambda A will give you, okay, complex conjugate of lambda, complex conjugate of A matrix. So lambda being any complex number. AB dagger equals B dagger A, just now we looked into. Properties of Hermitian conjugate. The Hermitian conjugate of any arbitrary matrix A is obtained by taking the complex conjugate of the matrix and then the transpose of a complex conjugate of the matrix. So this is your A dagger, we know already. A dagger, which is A dagger, what is how it is defined? We are going to take the complex conjugate and transpose. Take the complex conjugate, transpose, or take the transpose and the complex conjugate. Dagger of dagger will be the original. Similarly, A plus B whole dagger equal to A dagger plus B dagger. Lambda A dagger equal to lambda star A dagger. Okay, lambda is any complex number. AB dagger equal to B dagger A dagger. We will come to the end. Show that the following matrix is orthogonal. For orthogonal matrix, the condition is A transpose must be equal to identity matrix. So you have A matrix is given. A, you are going to have a transpose, change into rows into column, column into rows. So change column into rows, that will give you 0 1 0 1 0 0 0 0 1, correct? Now you multiply A transpose, this will be A and this will be A transpose. You multiply with the multiplication matrices, that will give you 0 multiplied by 0 plus 1 multiplied by 1 plus 0 multiplied by 0, like that. So we have 1 0 0 0 1 1 0 0 1. On simplification you will get, see, identity matrix. So A transpose equal to I. So very important condition for orthogonal matrix. So if it is orthogonal matrix, this condition should be satisfied. So we will get only identity matrix. The last one is show that the following matrix is orthogonal. So this matrix is orthogonal or not, we are going to find out. Again, A transpose equal to I will give you orthogonal matrix. So we have A matrix is given. We are going to transpose this matrix. So 1 by 3, 1 by 3, let it be. So change rows into column, column into rows. See 1 2 2 will give you, see 1 2 2. The second will be 2 1 2. See 2 1 2. The third one will be 2 minus 2 minus 1. 2 minus 2 minus 1. So A transpose. The condition is for orthogonal A transpose. So this will be your A and this will be your A transpose. You have to multiply 1 by 3 multiply 1 by 3 will give you 1 by 9. Of course you have to multiply this multiplication rule. So you have to multiply with the multiplication rule. So that will give you 1 by 9 and 1 multiplied by 1 plus 2 multiplied by 2 plus 2 multiplied by 2. See, will give you this answer. So we have 1 by 9 and this will be your 9. This will be 4 minus 4 0. So we have 9 0 0 0 9 0 0 0 9. You can pull 9 out We can pull 9 by 9 will give you 1. So 1 0 0 0 1 0 0 0 1, which is nothing but identity matrix. So if this condition is satisfied, then we can say that this matrix is orthogonal. So in this class we were discussing about the types of matrices. Okay, thank you students, we'll see in the next class.